Morning friends, this week is the 12th week, so go to the 12th week. Yes. So in 12th week, so before the lab, submit the lab report 9. Due date is this week. So now we are going to do the experiment number 10. The experiment number 10 is K factor for pipe fitting. So first of all, download this Word file and then open this file. So write your name, ID, experiment number 10, measurement of friction losses through pipe fittings. So you have to write on a blank report. I told you if you don't have the blank report, I told you the alternative, what you have to do. So presently I will consider you have the blank report. So you will write your ID, you will write your name, lab section, and don't forget to write the date. So objectives, you have to write the objectives from here. So K factor for pipe fittings. So first of all, we should know what are the pipe fittings. So there are different pipe fittings. So for example, elbows, gate walls, bends. So we'll see one by one in the on the equipment. So our objectives, first objective is to understand, identify the various pipe fittings. Second objective is to determine the head loss. This is common for all. Determine the head loss associated with flow of water through the standard pipe fittings, and to find out the K factor and Reynolds number. So as usual, we did the Reynolds number before. And to know what is the difference between shut-off valve and control valve. So watch the video carefully, and I explain there what is shut-off valve and control valve, on-off valve or control valve, which is on-off valve and control valve. You have to identify it. So this is about the objective, and this will be very helpful to write the procedure, to write the calculation table, to write the sample calculation, and we can add here to plot the graph between Reynolds number and K factor. So depending upon this, we need to write the observation, procedure, calculation table, sample calculations. So these are the mark distributions. Now pre-lab test, I will come back to the pre-lab test. Now procedure, you have to, we make a 4 groups, and group A there are 2 students, group B there are 2 students, group C there are 2 students, and group D there are 2 students. So you have to write the observation table for that. For group A, gate wall, so he has to use only for gate wall on arm field. Another group, globe wall on arm field, 45 elbow on arm field, 90 elbow on arm field. So we can do on TQ and arm gunt also, but today we'll go consider only arm field. Now observation. So in observation, this is observation in equipment. So you have to write, you have to underline gunt, TQ, arm field. So here we will underline arm field. Now you have to select a 45 as per the students. 2 students will select 45, 2 students will select 90, gate, globe, whatever given to you. Don't forget to write the diameter, and these properties are same for previous experiment also. Now observation table. So group A will write only arm field, gate wall. Group B will write only for globe wall. Group C will write only for 45 elbow and elbow. Now calculation table. So how to write the calculation table? It is very important. So first column will be the serial number and unit here. Then it is asked to find out the water head associated with the flow through the pipe fittings. So water head, what is water head? The H1 minus H2. So we have mercury manometer. So this is a mercury head. So we have to convert in water head. So first H of Hg is H1 minus H2. Then I can find a water head HW is equal to under root gamma hg over gamma water minus 1 bracket square into h of hg. So we can find out water head. So here the second column will be the water head. So I will go here, insert table. So 4 5 readings, 6 readings, I will do like this. Okay, so this will be a serial number, this will be a water head associated with, this will be the unit, and you have to write the unit in meters. Now from h1 h2 I calculated water head. Now from here volume and time, so I know volume, it is 5 liter, 5 into 10 to the power minus 3 meter cube. I know time, so volume by time I will find discharge, so I will write here discharge meter cube per second. Now from this given from the table, now it is asked to find out K factor. So for K factor what I need a velocity. So for velocity what I need area. For area what I need a diameter. See, diameter. So diameter is given. So go to the sample calculation, write first h of hg. So mercury h of hg is h1 minus h2. Number 2, write water head is equal to hw is equal to that formula I explained before. Then now third, discharge is equal to volume by time, put value, get answer. And now next is a flow velocity. So for that I need a area. So area of flow pi by 4 d square, find out area. Then I know area, then I can find velocity. So q is equal to av. So velocity is equal to discharge by area. So discharge by area I will get velocity. So once I get velocity, I will write here velocity. Then K factor. What is K factor? K factor is, that is head loss, HW. Head loss HW is equal to K into V1 square over 2G. So K is equal to HW 2G over V1 square. So we can find out a K factor here, and the last column will be a Reynolds number rho Vd by mu. So you can complete the calculation table. Now sample calculation I told you, h of hg is equal to h1 minus h2. Write value with unit and write answer. Don't write directly answer. Number 2, water head, write description, don't write only formula. So water head is equal to hw, first formula, put value, get answer. Number 3, discharge is volume by time. So you know volume, you know time, you can calculate. Fourth, area of flow, A is equal to pi by 4 d1 square. So put the value of d1 and find the area in meter square. Number 6, the velocity. So velocity of flow is equal to discharge by area. So you know discharge, you know area, you can find out velocity in meter per second. Next step, K factor for pipe fitting, K factor for elbow, for gate wall. So K is equal to HW 2G by V1 square or V square. So we can find K factor, and last step is Reynolds number. If it is as mass flow rate, you can find mass flow rate also. So this is about sample calculation, and plot the graph between K factor versus Reynolds number for gate wall, globe wall, whatever you have. Write the x-axis, y-axis. Now on x-axis, what is in x-axis? So we are going to change the velocity. So Reynolds number, velocity is related with Reynolds number. So Reynolds number will be on the x-axis. Y-axis, we are going to calculate K factor. So what we are going to calculate, that is K factor is on y-axis. And conclusion, write the answer of objectives. So we understand the pipe fittings. These pipe fittings are required various plumbing works. Number 2, we calculated the head loss through the whatever your pipe rating, 45 elbow, 90-degree elbow or gate wall. Write the head loss in meters of water. Then number 3, you can write Reynolds number for the flow is, so choose any one value and write the answer for HW, Reynolds number and K factor for that. So this is about conclusion. So now we'll move to the problem solving. How to solve the problem. So this problem is, I will solve this problem and I will give you another 2 problems or 1 problem or whatever. So with the help of this problem you can solve the another problem. So I will explain this problem. So pre-lab test. A water is discharged from reservoir. So this is called a reservoir where water is stored, and it is discharged from here to the atmosphere through the pipe as shown in figure. Taking into the account the head losses at entry. So here is a head loss at entry due to the sharp corner. So flow will becomes like a vena contra, I explained last week. So there is a losses associated with that. So at entrance, then as the water flow over this pipe 1, so the pipe 1 is having some friction factor roughness. So by Darcy equation we can find out the head loss over this pipe. Then after pipe 1 and entry to the second pipe, the head loss due to the sharp contraction, sudden contraction. So last week we studied sudden contraction, so we can find out head loss at the sudden contraction. Then as the water flow over this pipe number 2, so pipe number is having friction factor. So by Darcy equation I can find out head loss by Darcy through the pipe 2. Then entering to the 3, there is a sudden expansion. So last week we studied head loss due to sudden expansion. So we can find out head loss due to sudden expansion. Then over this pipe 3 due to the Darcy. Then at the entrance of pipe 4, sudden contraction. Then over pipe 4 and then at exit. So how many losses are there? We will count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to find the head losses at 9 head losses for this. So there is a sudden contraction. So sudden contraction, you need to use this formula, and where K is found from the graph. Then if there is a sudden expansion, here is sudden expansion, so you need to find, we need to use this formula, and where KL or K is found from this formula. For expansion, the V1 inlet velocity is taken, for contraction outlet velocity is taken, and K is found from the graph. And for sudden expansion, the K is calculated by using this formula. So we'll start this solving. So how to solve this problem? It is asked to find out the total head loss. What is the head? Okay, so here first it is asked to consider this head loss. Then this is pipe number 1, which is having length L1 and diameter D1. This is pipe 2 and having friction factor F1. This is pipe 2 having diameter D2, length L2 and friction factor F2. Then this is pipe number 3 having length L3, D3 and friction factor 3. Then this is pipe 4, same having L4, D4 and F4, and this is at exit. So first we need to write the dimensions as given. So length is given, length L1 is given, 10 meter. Diameter D1 is given as 0.5 millimeter, so it is 0.105 meter. Then F1 is given 0.002. Similarly, we can write L2 is 10 meter, diameter D2 is 0.07 meter, F2 is given as 0.0015. All the dimensions are same, so I will write L1 is equal to L3, L2 is equal to L4, and here D1 and D2, D3 and D4 and D3 is same. F3 is given 0.003 and F4 is 0.0035. This volume is given as 3500 liter, so it is nothing but 35 into 10 to the power minus 3 meter cube. The time is given to you 2 minutes, so minute is not, so we need to calculate second, 120 second. The K factor at the sudden entrance, here it is given 0.5. K factor at the exit is given as 1, and it is asked to calculate H. Now first, I know the diameter. See the flow chart. You know diameter, calculate area, calculate discharge, calculate velocity. If you know the velocity, class finish. We'll calculate the area. So area 3 is equal to area 1. Area 1 is equal to 3 is equal to pi by 4 d square, 1 or 3 square. So pi by 4 into 0.105 square is equal to dash meter square. Then A2 is equal to A4 is equal to same meter square. So I know area A1, I know area 2. Now my target is velocity. So area is known Q. So how I can calculate Q? So discharge. Discharge is equal to Q is equal to volume by time. So volume is given to you 3500 into 10 to the power minus 3 meter cube, and the time is given to you 120 seconds. So your discharge will be dash meter cube per second. Meter cube per second. Okay. Now once you know the discharge, you can find out flow velocities. Flow velocities. So V1 is equal to V1. This is volume. This is small v. V1 is equal to Q by A1, and it is nothing but V1 because discharge is same. So V1 is equal to V3 is equal to discharge by area 1 or 3. Area 1 or 3. So you know discharge, you know area, you can find out velocity. Discharge is meter cube per second and area is meter square. So you will get meter per second. See this meter square and this meter cube get cancelled. You get remaining meter per second. Okay. So once we know velocity, flow velocity V1, so you can find out V2 and V4 same, Q by A2 meter per second. So I know velocities V1 and V2. Now this is the basic you have to do. Once you finish the velocity, then we can write the formula one by one. So I will erase it. Now first you have to write this description. Don't write directly formula. Head loss at entrance. Head loss at entrance. I can write HW1 is equal to KV. Now entrance. What is the velocity? V1. KV1 square over 2G. So K is given to you 1. K at entrance is 0.5. 0.5 into velocity you already calculated, 2 into 9.81. And here you will get the unit meters of water. H2. Okay. So entrance finish. Now as the water flow over this pipe, so there is a head loss, and this is due to friction. So our experiment number 4, head loss due to friction factor by Darcy. So head loss due to friction through pipe 1, this is through pipe 1 by Darcy. So what is Darcy formula? HW is equal to, or HF, because it is a friction. So HF is equal to FLV square over 2GD. So some books, no, this is correct, and if you use 4 here, it will become fanning friction factor, not Darcy, remember that. So we are finding generalized formula, and which is generalized is a Darcy and FLV square. So this is friction. So this is for pipe 1. So here 1, F1, it is given to you. L1 is given to you. F1 is given to you. Velocity, this is pipe 1, velocity 1, and the diameter D1. So everything is given. Put the values and write your answer meters of H2, because water is flowing. Now third. Now water is entering in a pipe 2. So there is a head loss due to sudden contraction. Head loss due to sudden contraction. So there are sudden contraction, 2 sudden contractions, so I will name it as 1. So I will explain this in detail. So this is sudden contraction, and I will erase it later on. So inlet is 1, outlet is 2. So here it is D1 and here it is D2. So water will be flow like this. So what is the formula for head loss? Head loss is equal to K V square over 2G. So this is sudden contraction. Which velocity you have to consider? V1 or V2? This is very important. Students generally make mistake here. So I give you the last experiment example. It is difficult. If you drink water, remember that example. So V2. So I can measure the outlet velocity easily. So V2 you have to use. And K is plot from the graph. So graph is given to you in the word file. This graph is between D2 square by D1 square. So you have D2, you have D1, put this value, you will get some fraction because D2 is small, D1 is bigger, so you will get 0 point something 4 or something. And there is a curve for K factor. Okay, so 0.4, 0.1, 0.2, 0.3 or 0.4 here, go up vertically, and go here horizontally, you will get this number here, whatever from the graph. Okay, so how to find K? I explained. Now you know K, put value V2, put value here, and you will get HW. So HW is equal to dash meters of water, H2. So you understand? Now I will cancel this, I will erase this. Now number 4. So now we pass this. Now water will flow here. The pipe have friction F2. So head loss due to friction. Head loss due to friction F2 by Darcy. I will not write through pipe 2 because F2. This is through F1. So you can change here and you can write F by Darcy. So same HW is equal to FL V square over 2GD. So again this is pipe number 2. So you need to consider F2, L2, V2 and D2. So you will get the same answer, meters of water. Now fifth we are entering here now. Head loss, similarly like this, head loss due to sudden enlargement. I will explain this again. So now remember here, sudden enlargement means like this. Water is flowing. Now what is the inlet here? D2, V2. What is the outlet here? D3, V3. Okay. So what is the formula given to you? Head loss is equal to HW is equal to K V square over 2G. So this is sudden enlargement, sudden contraction, outlet velocity. Sudden enlargement, inlet velocity. What is the inlet velocity? V2 here. Okay, so you know formula, you can find out, put the values and get the answer, and you can write your answer in meters of H2. I will erase this now. Now come to the 6. Head loss due to Darcy. Head loss due to friction by Darcy. Head loss due to friction F3 by Darcy is equal to HW is equal to FL V square over 2GD. So F is 3 here, L3, V3 and D3. So now 6 finish. Now 7th. Now 7th number. Head loss due to sudden contraction. Yes. Okay. So here I will draw a diagram again to explain the things. So inlet is T3, V3. Direction is very important. Outlet is D4, V4. Now what is the formula? Head loss is equal to sudden contraction outlet K factor into outlet velocity V square over 2G. So here we need to take outlet velocity V4. And how you find K? K again graph. Now the graph between D4 by D3. D4 by D3 square. see it is given D2 by D1 previous, so the number will be changed because inlet, outlet over inlet, so it should be a 0 point something because smaller diameter over bigger diameter, 0 point something, suppose 5, so go to the 5, go up vertically, go horizontally, you will get K is equal to dash dash here. So put this K here, and V4 is already known, you can find out HW. Okay, so now I will erase this. Now 8, we finish this, flow over this pipe number 4, head loss due to friction, head loss due to friction F4 through the pipe 4 by Darcy is equal to HW is equal to FLV square over 2GD. So this is pipe number 4, you can write here 8, this is 7, go previous and change the number with this HW is equal to H7, that is 7 suffix. Now L4, V4, and D4, put the values, get your answer. Now last, I told you before 9, so this is last, head loss at exit is equal to HW is equal to K. What is the velocity at exit? V4 V square over 2Z. Now how to find K? Sometimes, now this problem, the K is given as 0.5. If it is not given, assume K is equal to, so assume 1, there will be no effect. So there should be some standard to assume. So how we can assume? See, at the exit, what is exit? This is a pipe, water is flowing here. Exit is having this. So this is a 4, and what is 5? Atmosphere. Okay, 5 is atmosphere and 4 is the pipe outlet. So head loss here. So this is a sudden enlargement, sudden enlargement. So what is the formula for sudden enlargement? HW is equal to K, inlet velocity V4 square over 2Z. What is K? K is equal to bracket 1 minus inlet diameter, so D4 square over D5 square. This is sudden enlargement, inlet over outlet, so this is a fraction. Now think here, what is the outlet diameter? What is the diameter? It is a infinity. So this will become meaningless. So it is almost anything by infinity is 0. So 1 minus 0 is K is equal to 1. K is equal to 1, and it is given. So remember that this explanation nobody will give you. It is understanding. So we know HW 9 is equal to K, I assume it 1, and outlet velocity V4 square over 2Z. So last, total head loss, total head is equal to H1 plus H2 plus H3 plus H4 plus H5 plus H6 plus H7 plus H8 plus H9, and it should be your meters of H2 water. Understand? So we'll stop here, and in the pre-lab test we have similar problem, not like 9, make it 5, 4, 5, it is depends on the picture or figure, so you can find and calculate. So pre-lab test problem is very simple for you, not including so many sections. So by using this procedure, same everything, only values are going to change, you can solve the pre-lab test. So I will ask the quiz by Google form. What is your answer? Select the tick answer and some theoretical question on this in the pre-lab test by a Google form online during your lab time. Thank you very much. Have a nice time.